Recording is on.
Again.
All right, so I got that. So I should turn my camera on.
And I'm sure we'll get one or two of the Kingston guys coming out as well. Don't know for sure, of course, but I'm thinking that.
Thanks for dropping the parts off, Eric.
Yeah, no, you're welcome. Yeah, no, it was nice to. Easy to figure out, that I'm at the right address. That's the nice thing about having so many pieces of metal in the air. So, yeah, no, pretty impressive what you've got in a fairly modest space. I guess, in the backyard there, right?
Yeah, well, it's 30 feet wide and 46 feet from the back of the house to the fence to the property line. So.
Yeah.
I got my tower there, and 30-foot tower with the mini quad on top with two 15-foot pieces of pipe to rotate the antenna, and the rotor is at head height, so it works. Rotators at head height.
Everything is attached to either a fence or the house, I suppose, right?
Well, the deck came first, and the tower is sitting on the deck. The base plate of the tower is sitting on the deck, and it's lagged into the chimney by those studs that you drill a hole and drive them in and then crank them out to set them properly. And it's been there for 20 odd years and no problems. So I check it every so often.
All right, but nothing, no freestanding towers like on a pillar.
No, I don't have the space for that now.
Right.
If I had it to do over today, I would think about putting a hex beam on the roof instead of the tower, but that means the hex beam would have to be placed pretty carefully so it didn't overlap the other half of the semi and also my neighbor on the other side. So yeah, it works. What I thought I got. It's not great, but it's okay on pretty well everything. 40 is not great. I use the R7 on 40 and it's so, but it works. Mm-hmm. Can't do much on 80 or 160.
Right. Oh, those hex beams are nice.
How do you like the mini quad?
Sorry?
How do you like the mini quad?
I love it. It's good. It's I bought it from Tom McKay in Stratford.
Yeah.
Years ago, I started with a 2-element mini quad, which did 10 through 20, and this one is 3 elements. So it's pretty good. Yeah, it's interesting. I get really good reports. If I talk to someone in Europe, usually they give me a 5.9 or so, and it's a real 5.9, I understand, but I don't hear as well as I am heard overseas, which is interesting. But yeah, it works. And I use a 30-meter hamstick pair for 30 meters underneath the mini quad.
I had a mini quad for many years and really liked it until the tree next door ate it.
No. Oh, wow. Okay.
I put it down one stormy day, and there it was on the ground, just a mangled mess.
Oh.
Has anyone ever seen or themselves made a homebrewed hex beam?
No.
You can be the first.
I'm just wondering, you see just about everything else in a DIY, it's been done, but that's one thing I've never, you just hear so many good things about them and you wonder how much experimentation goes on with them, right? So just a thought, that's all.
If you quit shopping, you'd have time to build one.
Yeah.
Well, this is the thing I did homebrew-wise, antenna-wise. We made, at the Mississauga Cloud, we made about 25 Arrow dual-band VHF antennas, the Arrow ones. There's a design on the web where you basically duplicate it, and we made about 25 of them in my basement and handed them out. That was an interesting project. They all work fine. It's about closest I've come to building any antennas myself.
Okay, well, I think we're at 5 minutes after the official meeting time, so that's I think a sign that's good to go. So welcome to our August AF Mixer meeting. It's Wednesday, August the 2nd, and I actually have the preamble here this time, so we'll read it out. Please note that all of our meetings are recorded and made available to the public for viewing on our YouTube channel. By participating in this meeting, it is understood that you have accepted these terms. So yeah, welcome all. I believe Wayne and Charlie, even Hassan have shown up after I've said hello to everybody. So welcome aboard, gentlemen. And one little bit of housekeeping news. It took me a while to get into our YouTube channel's admin account. I hadn't been in there since Dave's been doing most of that work, but I was looking it over, and I guess it was almost a fresh pair of eyes kind of thing. It says everywhere SOAREX, but I could not find a single page in the about or any of the text which actually spelled out what the acronym stands for. So I took the liberty to make an expansion right on the front page there, where people at least know what the definition of it is. Like I said, I don't know if it even I have it written out here. No, it doesn't say actually Southern Ontario anywhere. So anyway, just so whoever's looking at it has an idea. So there you go. Anyway, so that being said, is there anybody, like we have a couple people on the agenda for this evening. Peter's got a talk about RF measuring techniques. Michael, RF splitters. Is there anyone else that has anything that substantial that they'd like to talk about tonight? Yeah, I know. Quotations, substantial. This is the casual meeting after all, so. I know the pickings are usually pretty slim, but anyway, if not, we'll jump right into it. So who would like to go first? Do you want to do this alphabetically? Michael?
Okay.
Yeah.
I can go first. Sure.
Right.
Excuse me. Okay. Let me share my screen here. Can never figure this stuff out. There it is. Okay. So window, I guess. There it is. Okay. Everybody see that?
Not yet, but it's coming. There we go.
Okay.
Got it now.
And you can see you can see the next one. Good. Okay.
Yep. Impedance matching.
Okay, yeah. So what all this is about is at some point, I forget whether it's October or November, or maybe I can delay it till 2025, who knows. But anyway, I'm going to be talking about the Tiny SA the Tiny SA, and doing some comparisons with the signal spectrum analyzer. So there's a couple of videos out talking about the comparisons and how to do them, and somebody talks about an RF splitter, which you have to match impedances. So I sort of set out to do a bit of digging, and what I found was I'm gonna try going to. Sorry, just a sec. I'm gonna plug my battery back in. I'm gonna try going to the slideshow.
Full screen.
Yeah, there. Everybody see that?
It's not changed yet on my end.
Oh well, never mind then.
No, it hasn't changed here either. You probably have to go down to the toolbar at the very bottom there, Michael, near the percentage marker.
Oh, I see it. Okay, let's try that and see if that works. Does that work? Can you see that?
I think what happens is when you chose the sharing on Jitsi, it's probably stuck on this window. So if you chose like this tab or this window or whatever you got, you probably have to choose a different item to share.
Let me try that. Let me try that and see. Where'd it go?
I think that's why Dave always does his in whatever presenter mode. I'm
Now I
guessing.
gotta go back here.
No, Dave doesn't like using he likes to do the his way because he sees the slides coming up.
Right.
But I select
that
this presentation mode within the window, so it should have changed for Michael. Why it didn't change, I don't know.
Okay, I'm gonna try again. Let's see. I got window here, which is this one, and I've got this. Oh, that's not right. Just a second.
Yeah, because I don't know exactly
Sorry,
what you're
guys.
seeing, but it usually does give you various options to.
Okay, just let me see here.
Probably if you put it into presentation mode or slideshow
So
mode.
I've got sharing. I've got home, Chrome's tab, or I've got window.
Yeah.
Probably want window.
So I guess window. So okay, I've got the presentation right here. So okay. All right. So I'm going to do this the easy way. Okay. Anyway, so I started out looking at how to do this, and the idea is you have to match the impedances so that everything so I'm going to be connecting the tiny SA and the SSA 302X spectrum analyzers to my signal generator as a source, and the idea is that everything has to match. And I found this guy Ralph Gable who has this YouTube series playlist, Electronics for the Inquisitive Experimenter, and there's the link. So I shamelessly plagiarized, and so yeah. So the name of the game is to match stuff. So your signal generator goes here. Can you see the mouse? I guess you can see the mouse, right? I hope.
Yes.
Anyway, okay. So you connect your signal generator on one end and the two spectrum analyzers on the other, and everything because of the design of the RF matching device, it works. And this guy Ralph talks about basically it's nothing more than 3 resistors connected together, and you connect your source to one and your 2 loads to the other, and you use some formulas that he provides, some formulas to calculate the resistor values you need, because it's just a 3 resistor network. So basically for however many terminals you've got, the number n, you can calculate the size of the magnitude of the series resistor RS, and it's based on the number of ports and the characteristic impedance, which in this case is 50 ohms. And you can calculate the voltage gain or insertion loss basically across the device, across the matching network with a formula, and you can calculate the power output and the maximum input you can put into this matching network from your source, depending on the power output or the power rating of the resistors is how you do it. So anyway, so this is what I did. When you go through the calculations, you need 16.667 ohm resistors, and you do 3 of them, and you connect them together. Signal source on the left here, or the signal generator on the left, and the tiny SA on one output, and the SSA 302X, the real spectrum analyzer, on the other. And so this guy Ralph goes into the calculations that I just showed you, and he does a bunch of tests. And what he did to start with, this is straight out of his YouTube video. He started with this box. Would he happened to have the box? It's got 3 BNC connectors on it, and he just took the resistors and connected them together. And he's using, as I did, 33 ohm resistors. 2 33 ohm resistors in parallel gives you the 16.6. So that's what he did. And he just basically stuck it in a box, and no concern with length of leads and whatnot. And so that's what he did. And Then he went on, for reasons I'll come to shortening the leads. And these are 16 ohm resistors, or 16 ohm resistors, 1%. Basically, he just took basically 5% resistors or something in the first one. So he basically connected it together in the appropriate arrangement. Then he went to a PC board arrangement. These are 16 ohm resistors, the three of them, I think. Yeah. Oh, these are the resistors in here. And he did that, and he found that wasn't quite what he wanted. So then he went, in order to minimize inductances and the like, what he did, he basically took 3 resistors for each port. So each one of these is 3, 1, 2, 3, 1, 2, 3, 1, 2, 3 is another one someplace else, another set of 3, to minimize inductances and capacitances and whatnot. So that's his progression, and he shows in his YouTube video the results. So I copied some of them, and the first version, which is the long lead version, at the top of the graph that goes up, the right-hand scale is 1 gigahertz here, and the bottom is 1 megahertz or something. And down at the very bottom in the HF band, it's pretty good. It's 1.04 roughly, which is what I got. And you get up to the 6 meter band, and it's 1.12 to 1 at 50 megahertz on this version 2. This version 1 was just the version with the sort of loosely arranged resistors, and you can see it's way out when you get up. This is around 600 megahertz or something. It's horrible up here, and it's just all over the place. So then he tried. That's why he went from the one with the resistors with all kinds of leads sticking out to the version with the shorter leads. This one, and this is SWR here, and out here it's pretty bad. Like it's 3 to 1 or something at 500 megahertz. It's terrible. But for his, anyway, that's. But he was after something that went to a gigahertz, I guess. So the other thing you look at is the insertion loss, and you can see that the version 1. I forget which one it is. I think this is the version 2 here. I think they're comparable at the beginning, but they're not great either. All kinds of oscillations and stuff going on. So I looked at that and I thought, well, I can do that too. And I thought at first, so what I started with was this. I built this thing, and this is a little circuit, little piece of PC board. It's about, I don't know, centimeter on the side, I guess, something like that, with my 2 33 ohm resistors in parallel. These are 5% resistors from SAL with the SMA connectors, and this is as close as I can get to get everything close together. So then what you do is, here it is here, with 250 ohm resistors on the output. This is my testing. And the input goes here, and I used my nano VNA to check SWRs and insertion loss. And yeah. So this is what I got. And this is the HF band, 1 megahertz at the bottom, 30 at the top. So it's the HF band, and you can see that these numbers, there's 1.05 here. So it's pretty good. At the bottom, it's less than 1.05. It's probably the same as his 1.04 or so. But even at 30 megahertz, it's still less than 1.1, I think. Yeah. So that's our SWR using the VNA. And then I did insertion loss basically by connecting the input of one of the terminals to one side and the output to the other with the third terminal with the 50 ohm resistor on it. And you can see this is very close to, it's minus 5.87, pretty good, pretty close. And so it's pretty close to the 6.02, which is what those calculations show. So that's what I did. And when I started doing this, I thought, well, I can do better than he can, because I thought mine was pretty good. And then I looked at what he had got at the bottom, and he makes the point in his YouTube videos that at the lower frequencies, like 1 or 2 megahertz or whatever it is, it's pretty good regardless. It's where you get up in the higher VHF frequencies that things go to ratchet. Anyway, so that's the story. So I'll stop sharing if there's any questions, I can take them, or I'll just stop sharing.
Did you measure it
Good,
at
there's no question.
VHF just to see what it was?
Did
what
I?
you
No, I
got? Yeah.
didn't.
Okay.
No, I didn't. My single. Well, I only have the. No, I didn't bother. Or maybe I did. I forget. I might have done that actually. I think I did, and I got a curve that appeared to be similar to what Ralph got. So it's not great at the higher frequencies.
And the other question I
So I
had
guess
was,
it's all
did you go
about
through
inductance.
your stack of 33 ohm resistors and measuring each of them to try and find one that was pretty bang on?
No, I went to Sayel and bought a package of 6.
Okay.
Or 10, and I just put them together. I didn't bother.
Okay.
But and they're 5%. Sayel doesn't have any 1%, so they're 5%, not even the 1% that he used, and it's still pretty good. It's good enough for me because I now know I can, check out the tiny SA and the other spectrum analyzer using the nano using the spectrum analyzers with the splitter. I can do it, so that's fine. That's all I really wanted to prove here. Yeah.
Okay, Peter,
that's good enough.
you have your hand up?
Yeah,
Sorry.
Michael. Interesting. Are you contemplating doing using an SMT version, or maybe I guess it's not worth it since if you're only interested in 1 to 30 megahertz and it's almost perfect. I guess it's not much worth trying. But
And what did you say SMT was? SMD. What did you say that was?
You're gonna try an SMD version splitter?
No, I don't have those. I don't know. I'm not going to bother. I'll save my opportunity to screw up on SMDs with a more complicated project. Put it that way. But I suppose I could. But I just haven't thought that far ahead. So I'm just going to leave it this way.
So effectively,
and what Ralph showed.
Sorry, go ahead.
Big Burn?
No, go ahead.
What Ralph showed with his SMD version, the PC board one, which used surface-mounted devices, the surface-mounted resistors, at the higher frequencies, even though it was small. Like, let me go back here. This one. This is his first SMD one, and he showed that I think it was 500 megahertz. He showed. Well, yeah, he showed that it's still pretty bad. Like it's SWR is 3 to 4 or something, so it's not great. This one, the one on the right here, with the 3 resistors, 49.9 ohm resistors in parallel, is really good. Like it's good almost all the way out to 1 gigahertz. He shows. So since he's interested in 500 megahertz, he's fine.
So paralleling up a bunch of resistors is the best way to go then. Okay.
That's what he said. He said that the best way to go is to parallel the resistors because it minimizes the inductances and capacitances and the like. And that's what he did. And it's pretty good. Yeah.
I wonder if that's a transferable lesson for other things as well. A learning.
Yeah, I guess so. The idea of paralleling, he refers to that actually. He talks about, he says that the right way to do this is to put a bunch of resistors in parallel to minimize stray inductances and whatnot. So that's what he actually says that in his YouTube video.
Okay. Hassan, you got your hand up?
Yeah, this is interesting because I've always wondered how splitters and that work, because when you open it up, it just looks like a bunch of resistors stuffed in there. But I guess the real magic is in the measurements, right? And the tuning.
Well, you don't have to tune anything. This is the design, and if this is for 3, and if you hang a 50 ohm resistor here, and one here. Then what you've got at this point is two sets of 50 plus 16, which is 66.3 or something here in parallel. And you divide, and the parallel combination makes 33. And you add that 33 to the 16, and you're up to 48 or 49, which is why you see 50 ohms here,
Ah,
if I've got that right. It's that simple.
yeah, but
So
I guess
this end, so this end sees 50, the input. Likewise, if given there's a 50 ohm resistor internal impedance on the signal generator, so the same thing applies. There's 50 plus 16 to here and 50 plus 16 to here, which means you look on this side with a SA that's got a 50 ohm, an internal resistance of 50. It works out. It all works out. Anyway.
cool. Yeah, but I guess it's all in the
It's real.
component selection and stuff, right? And the
A big
care. It's all, the whole magic is in the component selection and attention to detail of the lead lengths and all that.
That's right. And for these are 5% resistors, so they can be plus or minus 5%, right? If it's 1%, they're much closer to the right values, and I guess the idea of putting them on the board with the design like this, you minimize all the stray effects, and it just works. Yeah.
Okay. And did you use a carbon?
I beg your pardon?
Well, did you use carbon resistors or the spiral around ones? Did you use special
No, I didn't. I just used the ones you get from sale in the bag, the standard ones, just standard 5%, whatever they happen to be. I don't know exactly what they are.
You couldn't use the wire wound ones, Sam, because you would throw inductance in there.
That's right, they would. Now, his design was carbon. This first design was carbon resistors. The ones I used are the same as these, I guess, whatever they happen to be. I don't know that I've got a package that I can even. Don't think the sale package even talks about what they are. I don't think it mentions it.
If they were wire wound, you would have had a really weird looking graph on your VNA.
They're most likely filmed.
Yes.
Yeah, I think they're filmed.
Yeah. Yeah. I can show you. They're just the standard resistors. Yeah. Probably carbon film or whatever you get when you buy them from DigiKey or whatever. Yeah.
So on the bottom right in that diagram, slide number 7, I think.
Which one?
With the 4 things on
this
there.
One?
Yeah.
This one, yeah.
On the bottom right one is, I'm trying to figure out what those are. Those resistors or what are those? I don't see where they are.
These are resistors. These are 16 ohm resistors.
They're stacked.
I think. I'm pretty sure they are.
They're stacked.
Yeah.
Well,
Big run?
they're effectively 50 ohm resistors stacked one on top of the other and soldered together.
That's right. There's three 50 ohm resistors, and together it makes up. In parallel, you get 16.6.
Right.
6.
Oh,
yeah.
That's interesting. I was wondering, can you actually make your own resistors with a carbon rod or something? You just cut it to the right length.
Where did I see stuff on that? I saw somewhere a discussion of taking what must have been the old carbon style resistors and notching them somehow to change the resistance. So you can do those kinds of things. But a carbon rod, I don't know. I guess in theory you could do that. Yes.
Yeah, because I saw this design for something, a resistor somewhere. One reference in a paper, it was an annulus. It was a donut, like a circular thing, and the current enters from the outside and exits on the inside. So if you did some kind of a funky geometry like that, you could build your combiner, your splitter that just looks like a kind of a circle of carbon.
I guess, yeah.
Carbon resistors aren't particularly popular anymore because they tend to drift with time and so on. So for a
Ah,
fixed science experiment, yeah, you could do that, but I think you'd be very unhappy if you went back to it a year from now. You'd find it was all over the map.
okay. Thank you.
Anyway,
Yep. I remember when I was talking about the physics of resistors quite a while ago when I did that little presentation. The carbon resistors were definitely a thing, so there's no reason why you couldn't try doing that, I think, Hassan. But yeah. Peter, you have your hand up.
Yeah, Michael, go back to slide 6, please.
Yep.
I think you said earlier, effectively, the two outputs, 1 and 2, were in parallel, but I don't see how they are, unless I misunderstood you. I still haven't quite, I don't want to belabor on the math a little bit here, but I don't quite follow a total of 30, like you got like a 50 ohms in your SA, and then you got a 16 ohm resistor and then another 16 ohm resistor going into the signal generator. So you've effectively got 50 ohms going into a 32 ohms going into 50 ohms. And that's matching?
but the signal generator is, let's see, if you take the two right-hand sides with the 50 ohm to ground, the 50 ohm load, dummy load, which I used, so you've got 66.6 to the T in the middle. Two of those makes 33.3. So you add the 16.6 on the left to that 33.3, and that means on the input you're looking at 49 point something, and your signal generator has a 50 ohm load, 50 ohm internal impedance, so it's matched. So the signal generator sees 50 ohms, which it needs to see. Yeah.
Okay, I got to think about that one. I think there'll be a question later on it tomorrow. But I don't see that.
Well, what do you look at it this way? What do you see? What do you see when you look at the input, looking into the circuit?
Well, for me, from my perspective, if I'm the signal generator, I'm looking at 32 ohms going into the tiny SA, which is 50 ohms, and I'm also looking at another 32 ohms going into the spectrum analyzer, which is at 50 as well. So I don't see how the T, the one that's teeing off, say, going to the spectrum analyzer, how it's affected by the 16.6 ohm resistor going into the tiny SA.
I guess, but the tiny SA wants to see, it's got a 50 ohm input into internal impedance, and it wants to see 50 ohms going into it, so it's matched. So the circuit looking into going to the left from the out one would be 50 ohms if it was matched to the tiny SA 50 ohms.
Actually, I think I see something now. I still have to think about it, but I'm looking at it a different way now. So I think I see what you're talking about.
Yeah.
Actually, they are together in a way. Okay.
Yeah. Think of the tiny SA as being a voltage source behind a 50 ohm internal impedance. So it sees on the left.
No, I see now. I see now, Michael. I see how the tiny SA is affected by the SA and vice versa. So, okay, I understand. Okay.
Yeah.
Thanks. I won't do a follow-up tomorrow.
What remains to be seen is how this actually works. It's the ISMAI guy. He's the one that talks about using a splitter, and in his comparison between the tiny SA and the SSA, and he talks about, he uses a splitter, and this is what he's using. It's a commercial splitter, I think. So he just connects everything up, and I guess what it means is the output power, the power you get, or the dBm power you get out going into the SA and the tiny SA, is equal because of the circuit design, and it's less than what's coming out of the signal generator, and you can calculate that, I guess.
Okay.
Yeah. Okay.
Hassan, go ahead.
Yeah, Peter, another way to describe this is if you had just a signal generator going to one spectrum analyzer, it'd be 50 ohms coming in, 50 ohms in out one, and all you need is a straight wire, right? So that would be balanced. So now you have two outputs. Each one has a 50 ohm load attached input. So now those two would combine and you would see 25 ohms. So what do you do?
That's the point.
Yes. So what you could do is you could in theory you could just add 25 on those two legs, and then looking in on the input side you would still see 50 ohms. But now it's not balanced in both directions because out one would not see 50 ohms. He'd see something else. So the easiest way to do it is 50 divided by 3, which is 16.67 on each leg. And now it's balanced in all directions.
Yeah, I see it now. I couldn't see it when I first looked at it, but I understand now. Thanks.
Okay.
And the formulas are right here. This is the formulas that you use to calculate. If you got more than 3 ports, then you change the values appropriately.
Yeah.
Yeah.
Okay.
Okay. I'm going to stop sharing.
Okay, thank you, Michael, for that.
Okay.
Yep, good talk, and always available on the recording if you want to go over it again for those that didn't catch it on the first time. Peter. So, oh, sorry, sneezed. Anyway, don't worry, I'll pay for that. I know.
Where's Dave when I need him?
That's right, you're solo tonight. All right. Well, on that note, Mr. Ayerst, RF measurement techniques. Are you ready to share some of your?
Yes, I'm ready to drag everybody into my rabbit hole.
Everybody take an Advil.
By the way, Peter, where did you get the nice slide? I like that.
I Googled it. I can't remember where I got it, but I Googled it. And I just Googled and found something I liked, and I think I edited some of it. Anyway, you guys can see that?
Yep, looks good.
Yep.
Okay, I've added something here. If you notice below where it says Techniques Part 3, it's a little bit hard to see, but I got an infinity symbol in there. And the reason for that is because RF measurement techniques, when I started this, back in February, or actually years ago, it's never left me. And it looks like this topic for me anyways is going to be a never-ending story that's going to go on and on and on. But hopefully if I bring it to you guys, it's going to be somewhat interesting.
Now, is that the current SOAREX logo? I see it is iterated quite into something quite fancy.
Where, the upper left one, you mean?
Yeah.
No, that's the logo for the Phoenix transceiver.
Oh, okay. Well, it kind of looks like SOAREX. No?
No.
All right, fine.
Okay, just a little bit of a... I can make some notes here. Where are we here? Oh, yeah, okay. This slide and the next slide is basically the RF receive chain for the Phoenix transceiver. And really, if you want to make low level power measurements, there's really no convenient spots. I mean, on here, with my mouse here, you can see that there's a test point here and there's another test point there. But of course, then there was always an issue, especially if you remember from our last discussion where Dave and I got into our different ways, like winding a coil around a toroid, or in Dave's case, he would lift the mixer out of the socket and put a load resistor in there. But none of that is convenient or easy to do. I want to maybe make a measurement here, the input to the 1253. I may want to make a measurement here, and these kinds of things. And so those methods weren't going to work. So I had to come up with something else. And I did talk a little bit about, or float out there about a scope probe, which was met with silence, except for Dave. He poo-pooed it. But anyway, it never left me, and I thought, well, okay, then there's the active probe stuff, and I went back to the scope probe. I did. And here again, here same thing. There's really no convenient way of getting your spectrum analyzer into these type of areas that I'm pointing out, other than maybe taking a turn around the core or put a load resistor in here, which I never really liked doing. So I thought, well, you know what? I'm not all that interested at this point in an absolute measurement. I'm happy with relative measurements, and let's just see how it goes. So I just went and got my 10x probe on my scope probe, and I plugged it into the spectrum analyzer and said, okay, let's go through this and see what's going on. And the main thing, the reason it really drove me to doing this is because I did have a problem with the Phoenix receive chain. It just was not working very well. I think I needed like an S7 signal in order to even begin to start to hearing something. So this is just a quick thing how Dave hooked up his stuff to measure with a spectrum analyzer, and for me, this is just illustrating where I just wrapped a turn around the toroid, and then here's just a quick review here of what it looked like when I decided to make comparisons, and really, except for the upper left, the other three are showing that the profile of the filter is they're similar no matter what method you use, 1 turn, 2 turns through the toroid, or the 1.2K load. The upper left is just no load at all, which is not really relevant because it's not a real world thing. Your ripple is extreme, and that's not what you have when you have the appropriate loads on there. And this is just a little bit of a close-up of the 1 turn connection. So I got the 10x probe connected to my spectrum analyzer, and I just started making some measurements. So I started off with the RFN, and sure enough, I can see a signal. It's down there around minus 97. Who knows what it really truly is? I can't remember now, but off the top of my head, I'd like to think there was about a drop of about minus 40, I want to think, loss. But anyway, wasn't, like I said, I'm not really concerned with the absolute measurement. So the output of the first stage of the 1253 is here, and we're showing a relative gain of about roughly 20 dB, which is correct. And then the output of the second stage of the 1253 is here, and again we end up with roughly another 20 dB gain, which is correct. So that's looking good. Band pass filter in. I'll just go through these quickly, and then I can summarize shortly. And then the band pass filter out shows a little bit of a loss. So, okay, that makes sense. And then the output of the matching transformer here, reading off here, okay, I'm getting back almost to what I've lost. So, so far so good. I come to the mixer input, the test point 3, which is the like I said, the input to the 612. And this is just showing that's at 7.2 megahertz. This one here is the VFO in, which is at 19.3 megahertz. And over here is the output on pin 4, and I've got this set to read what's going on at 12.151 megahertz. And something's wrong. I've got a huge loss coming in here. One advantage, supposedly, of using the 612 or the Gilbert cell is that there's supposed to be a gain. Data sheet says at 45 megahertz, you're going to get about a 14 dB gain. Not sure exactly what you would get down in the HF band area. I've never run those tests, but that's probably in the book somewhere. But either way, there should be a gain and certainly not a big loss. The problem here as well was I had taken the toroid cores off of the proof of concept board, which did work great. And I put them into the Phoenix board because I was down to about 1 week before we were heading off to 4 days in May, and I needed to get it up and running. And I did not want to, if the Phoenix didn't work when I powered it up, I didn't want to have to start worrying about toroid cores. So I just took them out and put them in. As much as I hated disassembling the POC board, because like I say, it worked really well. And of course, now I was also getting distracted because of what was going on with the with the 612. So I started reading a little bit more on the 612 and started looking for LT Spice models for the 612 as well. So I was getting pulled in a couple of different directions. Crystal filter, the outputs here. Again, there's a little bit of a loss, about 5 dB approximately. So okay, we're cool with that. And then we're into the next mixer after the crystal filter, and you can see a little bit of like here and here. You know, it's only about 1200 kilohertz away. This because this is where I'm now converting into audio, although I'm not reading the audio here. But I guess this is, I don't know, it's probably leakage coming in from the BFO side. I don't know if it's you know, just parasitic across from the chip, which Dave did find was happening, or whether it was something going on with the chip itself. I'm not sure, but either way, it was there, and it doesn't really show up as to being a problem regardless. But I'm not too worried about what was going on by this time, because I knew I had a bigger problem with the 612 that led into the crystal filter, not the next one. So to try and get a little bit better handle on what I was looking at, I decided to graph the thing, because up until then I was just basically putting numbers on pieces of paper and then referring back to them. And then when you spread that over a couple of days, it doesn't tend to work very well, and you're running tests again. So here I'm just capturing what I've just talked about here, and I can see, you know, this is the 7.2 megahertz chain, and everything's looking good. Each stage is increasing. The bandpass filter, okay, a little bit of a decrease there. That's fine. Get it all back at the matching transformer and then into the mixer. Over at the mixer, and then this is just the BFO, VFO in number. But here's the big number here from comparing this one here, and this one is showing that there's something wrong. There is a little bit of a decrease down in here between the output of pin 4 and the crystal input, but that's probably because of the matching there. In through the output, that makes sense. And again, these all make sense. And I'm just disregard this one here. So again, we're worried about here. So conclusions, observations so far, the problem appears to be in the area of the mixer. Of interest, though, the receiver did work in both the proof of concept board and the Phoenix boards. And it's and I can't really explain the Phoenix board, why it worked. Matter of fact, it's gotten to the point where I'm almost questioning myself, was it working properly before I left for Dayton? But all kidding aside, yes, I know it was. But I can't explain why I'm getting the results that I am now, and it'll come obvious later. Mainly because I used the toroids from the POC board. By now, I was starting to think I needed to rebuild the POC board because I wanted to validate the measurements. And that meant rewinding new toroids, get that up and running. I also had to make some other repairs to the that board. And the audio board, I had an outboard audio PCB, and that needed some extensive repairs as well. So there was another way to get dragged off into another direction for a while. I wish I made some of these measurements when both boards were working properly, but I didn't. So I'm starting from blank. So the lesson learned here is when I get a board working, make the measurements and then record them. Bit of repeat here. Absolute measurements into non-50 ohm load can be questionable. Relative measurements using various methods in the scope probe in this case seem to provide both the convenient and satisfactory results, in my opinion. Either connection methodology will work for determining filter profiles. I'm talking now here about Dave's method and the method that I had used. And now going forward, the scope probe technique set for 10x. And I found this works out really, really well. Stick your probe wherever you want it, and make a measurement. And it's a good way, I think. So what happened now that I got the proof of concept board up and running, I'm making measurements there. I'm redoing measurements with the Phoenix. I had to really come up with something that was a little bit better to record the numbers so that they would make some sense. So now, but even having done that, you still get a lot of numbers there. When we start going through them and making comparisons, you can kind of get lost a little bit. The big glaring ones, like the one that's coming from the input to the mixer and then out again, is glaring, so that sticks out like a sore thumb. But it might be something else going on that you don't see, at least initially when you're looking at just a bunch of numbers. So I graphed this one as well. The proof of concept board is in the blue, and the Phoenix is in the orange. And you can see off on the left there, we start off, they're all matching pretty well. You get up to the output of the LT1253, everything's looking pretty good. Although now I'm looking at this and I'm thinking, okay, so something's going on here that's unusual. You know, it may not be huge in some ways. Well, actually it is 88 to 94. So there is a big drop there. And all that's going on here, if I went back to the schematic, is you're looking at a resistor from here over to here is nothing but a resistor and a capacitor in series. So they're really, you know, what's going on there. So I had some advice on the weekend that maybe I got a crack or in the resistor chip or something like that, but I have to go back and check on that. So all things being equal into here, into the bandpass filter, or sorry, not equal here. As far as the proof of concept board is, from the bandpass filter input to the bandpass filter output, I got a little bit of a loss. That makes sense. Now, this did not happen when I made my initial test with the Phoenix board that I showed graphed there earlier. But now, all of a sudden, I've got an increase in amplitude here with the from the bandpass filter. So bandpass filter in is at minus 94, and the output is minus 86. I made this measurement many, many times. I even turned off everything, powered everything back up again, and sure enough, it shows that. So I have no idea what was going on there. I know I mentioned on Saturday, Charlie, I mentioned something about some DC bias going on, but when I looked at the schematic, that can't be what it is. There's got to be something else going on. I'm not sure what, stray of something, but anyway, something, another thing I have to follow up on. So there's two items, and then here's the big drop. There's the drop there going on with the output of the 612 versus the input. And if you look at the proof of concept board, you can see there is some gain. It's about a 3 dB gain roughly. And here, well, it's too big to talk about. So definitely something's going on. And I didn't pick up on it right away, but I'm now noticing the difference between the BFO, sorry, that says BFO, but it should be VFO, inputs to that chip. And there's quite a difference here. So when I looked into that, I realized that when I was doing the proof of concept board, I set the power level to the mixer via the settings on the SIGGEN. On the on the Phoenix board, we put in a dB pad. I forget how many dB it is now, but we put that in because Dave and I were using the Park SIGGEN and repurposing that into the controller for the Phoenix, and the outputs on that unit is hot. So we put the pad in there to take care of that. So I'm hoping, now I did do a little quick test of increasing the BFO voltage, and it did start to come back up, but not really what I expected. So anyway, I put that off to the side for when I had more time. But I'm hoping that this is hopefully that this is where my my problem is. And if you look at if you take out all these abnormalities and you stick this here, you can see the trends actually match here as well with the proof of concept board. So if I got rid of this, then this all ends up, so things should be good again. And Dave's Phoenix is working very, very well on the receive as well, at least matching what I've done on my proof of concept. So I'm confident that that's where the problem is. But certainly, I think the way I laid out and shown with the spectrum analyzer using the 10x probe is a good way of going about troubleshooting the various spots on these boards. And the other one that highlight, I think, really importantly, and I don't even know why I originally put this one in there. This test point, I just stuck it in just because of the way I felt when I did it. But it was only just because it wasn't anything that I thought was super important. and it actually started to highlight something. So that was interesting as well. And I think that's what all I've got for this little segment here. If anybody has any questions. Okay.
There we go. Wayne.
Yeah, Peter, I'm just a little uncertain what you mean by the 10x probe and the spectrum analyzer. Are you actually connecting an oscilloscope probe to the spectrum analyzer, or is that, or using?
Yes, I am. I'm just taking the standard scope probe, leave it on 10x, and probe away.
Okay.
And what about the attenuation, or did you use any attenuation between the scope and the probe, or the scope and the SA, or what? Or do you not worry about that? The signal level.
No, I just put the probe on 10x and connect it directly to the spectrum analyzer. Like I said earlier on, I wasn't worried about absolute measurements. I was only concerned about the relative measurements between the various stages of the signal chain.
Okay.
See, there was two ways I thought about going about this. The one thing that one track of mine I had going, and I'll talk about that in a minute, is an active probe. But how else could it, why could I not use a probe on the spectrum analyzer just to probe that as I've done here? Yeah, the absolute measurements are going to be off. But again, if you're not worried about that, so I think showing here, like what I've done, I've probed with that scope probe on my SA, shows that the relative measurements seem to be accurate in as far as telling you what something is right, something is not right. It seemed to show like if you looked at the proof of concept board lines, everywhere those lines go makes sense. So when you go to the Phoenix board, you see, yeah, okay, there's some things there that do not make sense with the same test setup. So I think that using the scope probe on your spectrum analyzer is a viable test method.
It's not going to damage the spectrum analyzer is where I was going.
Well, you're talking really low power levels here. You're talking
yeah.
And you got to go pretty high to what's the
This is dBm on the left, isn't it?
Yeah, that's all dBm. So
okay, yeah. So you're way down. Yeah.
The spectrum analyzer can handle plus 30 dBm.
That's right. Okay. Yep. Got it.
Charlie, please go ahead.
Peter, I think if you do some analysis, resistor analysis, like the previous presentation was doing with matching impedances, you'll find that you'll have, whatever your source impedance is, say that's, 200 ohms or something at that point, the scope probe will look like a 10 meg resistor and then 50 ohm into the SA. So as far as the SA sees looking back into the circuit, it's seeing a very high impedance. And so it would probably see the voltage being roughly around, maybe double what it would expect to see if it was actually a 50 ohm source that was feeding it.
Mm-hmm.
So I don't think, what you're doing seems perfectly valid to me. You're, you got to deal with a slightly higher voltage, but if your signals aren't all that big, no big deal. And if you wanted to get a view of what the absolute measurement was, if you divide by 2 what your absolute measurement is, you'll be pretty darn close to what it really is. But for relative, it should be bang on.
Yeah, and that's what I was thinking, Charlie. If I wanted to do an absolute measurement, yes, then I'm gonna have to rethink that whole thing. And I don't know how you would go about doing that unless you're involved in an active probe. And again, I'll come back to that one. I can't see the screen, so if somebody else has a hand up.
Nope, nobody at the moment.
Okay. All right. So to that, I do have a little bit of an active probe update. Discussions of doing an active probe has been ongoing for a long time, and it's resurfaced again. So I managed to go and borrow an active probe off of Dave V3 EAC here on Wednesday. This probe here is the one that we all know is the poor man's active probe that was circuit that was published in Elector magazine, and then some guys in the Ukraine took that circuit and they produced a board, and that's what's in this pen case. So Dave put it in this case and wires and all that kind of stuff, and graciously lent it to me. Now, if you see this little thing right here, unfortunately, when Dave lent it to me, I broke it. This is what they call those, I think, a pogo pin. It's a spring-loaded pin that goes in here, and that's what you probe your circuit with. So I did manage to get a few measurements done, but I needed to redo them when the pin popped out, and of course you can never get them back in again. So I have to talk to Dave a little bit more about how we could go about to repair this. But I did make some more measurements that I'll go into more details at another meeting. But I managed to stabilize the probe and a wire, and I, for lack of a better word, jammed a piece of wire into the hole of the outer sleeve of the pogo pin, and was able to make some measurements. From what I'm seeing, you can get down to about a minus 75 dBm, give or take, with a really linear curve up to plus 5 dBm. I did not go any higher than 5 dBm. I just chose that's where I was just going to stop measuring, and it's quite linear from that down to about minus 75. After minus 75 or so, the curve flattens out big time. So if we're interested in stuff down in the minus 100 areas and minus 80 from 90 areas, then this probe is probably not going to do it. I'll have to do some rethinking on it. But anyway, that's what we've got so far. So encouraging in one way, and but more work needed. And that's all I have, Eric.
Okay, Peter, thank you very much. And by the way, welcome, Howard. I see you've joined us this evening. So nice of you to be here. So brings our head count up to 10 for the night. So okay, so yeah, thanks again, Peter, for that update on the ongoing saga of the rising bird. When will it end? Nobody knows, right? All right, so this brings us, we're at about the hour mark now, to the round table portion of the evening. We share what's on everybody's benches. So I perhaps will start with myself, since I am first on my screen as it happens here. So as far as radio related things, because by far the front burner topic is probably still what it has been for the last 2 to 4 weeks for our last meetings, which is getting my old house prepared for sale. I'm there pretty much every day doing things. Unfortunately, found lots of water in the basement. I'm taking out about 30 liters a day under the finished floor that has come to light. So yeah, not good. But
Good ground playing.
What's that?
Good ground playing. Throw some salt.
Very good ground. That's right. Just add some salt to it, and Bob's your uncle. So anyway, so one thing I'm working on, which is kind of just a little prototype here, but I've made a box. This is all in laser cut, castellated edges and that, but trying to make an enclosure for my S-Bitex, and you know, all of the associated cutouts for the display and controls and all that. So anyway, this is held together with nothing but my hands and friction right now, but that's kind of what I have in mind as 3mm ply to build it out of. And anyway, so an ongoing project with the laser cutter at Y-Lab in Richmond Hill. So I'm working on that. Last meeting, after everybody left, Drew was giving me some hints on what might be wrong with my end-fed antenna as far as the horrible matching that seems to be happening. There is a single capacitor in the matchbox that, you know, I guess soaks up DC. I'm not sure, but anyway, one curious thing. I don't know. Maybe somebody can mention or can help me with what I saw here. I couldn't figure it out, but he was suggesting check the capacitor to see if somehow it has failed, got blown, whatever. But so I wanted to see if the I put it on a meter, capacitance meter. The code on it's a ceramic, a disc cap is 120 and then J, which is I think the tolerance, right? 120 to me, from what I understand, is a 12 picofarad. And correct me if I'm wrong, but whenever I put it on the capacitance meter, I get 120. So am I doing something wrong, or is 120? Do they sometimes just label it with the capacitance right on the capacitor? It's kind of misleading. So any comments from anyone assembled here?
Well, the code 120 is will be your 120 picofarad capacitor.
Yeah.
It is? Okay, because what I was looking at was you look at the first two, which are the significant figures, and then the third digit is the multiplier. It's to the power 10 to the power of.
Yeah, but 121 is 120. So there you go.
So, okay. But wouldn't that be 12 to the times 1, basically?
You're right. It's just that they don't apply that rule until you get to the first digit, starting with the last digit starts with 1.
Oh,
right. So in order to go up to 100 in the hundreds, say, yeah, like 1 to 99 is 1 to 199 is what you see.
right. Okay. All right. So 120 is what I should have expected on the meter. So, okay.
You've nabbed me a few times too.
Right.
Download one of these, Eric. It helps you.
Yeah, well, I kind of do have that, and like I said, when I look at the code for 120, on this chart I'm looking at, it shows 12 pico. So obviously I've got a bad chart. So
well, no, 120 means you don't have that extra 0, right? So you're down to 12. 121 means you're adding a 0 to the 12, hence 120.
120, that's right. But I have 120 on the
so 0 means nothing. Don't add anything.
No, they'll use capacitors. Will use 12. The ones I see, anyways. I shouldn't make flat out statements. All the capacitors I have that are small value below 100 don't have a 0 on the end.
Well, like here, for example, this code chart here for a 10 picofarad capacitor, the code is 100. So a 15 picofarad capacitor is 150.
I have never seen one. I'm just saying,
Yeah.
I always see 15.
Yeah,
you're seeing a table, man. I got capacitors.
Yeah, I mean, you're right.
Drawer. That's what I'm talking.
I'm just trying
That's
to
what I mean.
10 picofarad capacitor. Yeah, who knows?
Charlie?
Might be.
Yeah, Eric, I've built several end-fed half-wave antennas, and that capacitor should be on the order of 100 puffs. So if you're measuring 120, it's good.
Yeah,
I usually,
getting 120, 130 somewhere in there. So
yeah, I usually put something like a pair of 220s in series to bump up the voltage, because that cap can see a fairly high voltage.
okay. All right. Well, that answers the question even better, I guess, because I have no idea what I should have looked at that from that angle as well. What kind of cap would you put into a multiband end-fed? So, or any end-fed, I guess, for that matter. Is it always around that mark, regardless?
At least the ones I've built. The ones I've built have been, for starting at 80 meters and up, or even 160. Those were the values I was using. So,
right. Okay. All right. Very good. Very good. I'll just share this as well. Not exactly radio related, but just briefly. I might have mentioned this last time, but I have a very long driveway that would cost a lot of money to bring the fiber that was laid a couple of years ago along the road up $2,000 or so is what they wanted to trench it through. So I think this is visible, but essentially just a quick diagram of what I'm working on, which is instead of trenching and laying fiber all the way up, I'm doing some wireless. So got about 180 meters to get to the barn, which is building A. So doing that wirelessly. And I do have power at the post, which is at the end of the driveway. So cable's already trenched to the post and just waiting for the provider's equipment to show up, the optical network terminal. And then I've got the antennas. Going to get that to the first building there, and it's going to supply the apartment where our daughters are living, plus that's where my shack is at the moment, and then a lower throughput pair of antennas to get back to the farmhouse, which is building B, which is a fairly modest distance there. Those light beams are rated for 15 kilometers, so should have no issues there. But anyway, so kind of radio related, but not ham radio related, I guess. And I'm only going with 100 megabit connection to start, but those gigabeams are in the 60 gigahertz. 60 gigahertz, 60 gigahertz. Does that make sense? Yeah, it does. 60 megahertz? No, I don't know. Too late, too tired. But anyway, throughput is, I think it is 60 gigs actually. Can do up to a gigabit connection. So anyway, that's what I'm working on. That's, I guess, radio frequency related, but there you go. Yeah, Hassan.
Yeah, quick question. Isn't it possible to just put plastic conduit like below the surface of the ground and run the fiber optic through there?
Yeah, it's just I can do this with the antennas for about a quarter of the price. They want $10 a meter to get up the driveway. So at 180 meters, that adds up. So yeah, so sure, it could be brought up. I mean, I don't feel comfortable making fiber connections myself. I mean, maybe they would do it for a little less if they just had to hook up at either end. But you know, these antennas are not particularly expensive, so that's my strategy anyway. Since I do have power at the bottom, just put it in a weatherproof enclosure, the equipment down there, and that's that. So.
That's awesome, though. It's nice to see, you know, gigahertz local connections like that.
Mm-hmm.
Yep.
All right. So anyway, that's what's keeping me busy these days from a tech point of view. So Peter, you're next on my screen.
Okay. Well, of course, Phoenix has taken all my time virtually, but the only other thing that's really going on in the shack is I picked up that LT Spice model for the 612. So I've been messing around with that a little bit, trying to learn a little bit more about how to use that. And that, of course, has created more questions on using LT Spice, like how to use a measure statement with reading frequencies and all that kind of good stuff. When you have a mixed frequency domain, calculating it with a single frequency is not an issue, but when there's a multitude of frequencies, it's an issue. So, but other than that, other than that in Phoenix, that's it.
Okay. All right. Thank you, Peter. Al, you're next on my screen.
Okay, unmuted. Well, I don't have a lot to offer today. I've been on vacation for a couple of weeks, so I'm back in the saddle. So I think what the next thing I'm going to get on to, I think I mentioned a month or two ago, I had built a little QRP transmitter called a Warner. I think I showed people that before, and originally I was having some issues, but got it up and running. A good solid 2 watts out of it. Well, a drawback I've got is when it's not being keyed, I get some bleed through. The oscillator is continually running, and it's being keyed with a PNP transistor in the JFET circuit. So I'm not sure what to do right now. I'm considering redoing the PC board with a ground plane. Maybe that'll help. One thing I did do, it might be a problem, I'm not sure, but since I was considering this was just some development, you can see all my transistors are sitting fairly high up. I didn't want to trim the leads because I was putting them in and out. And I'm wondering whether I'm getting some crossover between the oscillator section to the output lead. So I think the next track is maybe try to rebuild it with a ground plane and get those transistors right down close to the board and see what happens again. But when I have it there sitting there idling, the receiver's humming away, even though when I do key it, I got a great signal, but something I got to deal with. Don't know anybody else has ever had a problem like that, but anyhow, I'm learning and experimenting. Pretty much that's all I got on the go right now. Probably I'll play with this over the next week or two and maybe have something to report next month. That's pretty much it.
Okay, Peter had a question for you, I think. Comment?
I was going to make a comment. I was going to, if I would bet a beer on it being the leads being that high, probably acting like a little bit of an antenna kind of thing going on there. Might be interesting just to cut the leads down to size now and just see what kind of an improvement, because if you went and redid the board with a ground plane and cut the lead, you're making 2 or 3 changes. You don't really know which one or how much of each one contributed to the solution. Anyway, that's my 2 cents worth, Al.
Oh, thank you. Well, certainly I now have spare transistors, so now I can afford to sacrifice a couple. So probably what I'll do is get them right down close to the board and see. The magazine article did not use a ground plane, so I'm just not sure. You're right. That's probably the very first thing I should do, and it'll only cost me a couple dollars in transistors. But so I'll do that. And I'll let you know, Peter.
Frank's got a comment for you there, Al.
Hey, Frank.
Yes, Al, what I would do with it is to start playing around with shielding that oscillator.
Okay.
And you can do that without any physical change. Just get a piece of PC board material and ground it, and then put it in different places between the oscillator and the rest of it. But a shield around the oscillator would probably work best.
Okay, great. Thank you. So some good tips there. I'll keep you informed next meeting.
Okay.
What frequency is that running at, Al?
Well, the article says it'll do all HF. I certainly got a crystal. What is it? The 7 or the 40 meter calling crystal. So it's a 7.30.
Yeah. No, I'm just wondering, like at that frequency, would the lead lengths still make a difference? Is that it's a possibility, I guess, right?
Well, they are pretty close to each other. You can see there's the crystal standing tall on the leads, and right beside it is the oscillator transistor, and then the 2 power transistors are the ones with the heat sinks on them. So they're pretty close quarters.
They're tall, but yeah, no, I don't know. Whenever I read about lead lengths, that always seems to be a factor when you're dealing with the really high frequencies. The higher you get, the more you got to look at that, which I'm sure it's still true. But anyway, curious. Okay. I wonder if would a ground plane, could you do that could you just glom that on instead of redoing the PCB? Like, could you just put a piece of copper clad close to the PCB and make a ground connection to it? Is that a simple way of making a ground plane?
To be honest, I like Frank's idea better.
Yeah. All right. I think Michael's got something to add as well.
Hey, Michael. I think you're muted, Michael. There you go.
Speaking about lead lengths and the like, I built the LBS project. I never did get it completed, but I did stuff like I made. Can you see, where is it? There it is. This is the where is it? This is the bandpass filter, the 40-meter bandpass filter, and I didn't pay any particular attention to lead length, and it works. It works on 7 megahertz just fine. So I was quite surprised to find that it really didn't seem to matter, lead length, at least for that. And the same thing when I built a crystal tester, even though it was 7 megs or something, it didn't seem to matter really how long the leads were. I was quite surprised because I had always thought that that'd be an issue, but it apparently is not a particular issue at HF, at least what I was doing. No, mind you, I wasn't doing oscillators, so I don't know, but that's my thought. So maybe it doesn't matter too much, but I don't know.
All right, Peter.
I know on VHF and UHF it really does matter, but for HF, what little experience I've had sort of appears to say, well, it really doesn't matter a whole lot. The circuit still works, put it that way. I don't know.
So maybe the shielding is the first thing to try after all. Yeah, Peter.
Yeah, this is interesting because it all depends on what instrument you're using to measure. And the reason why I say that is because when I was doing some work with the active probe, I noticed that even if I had things disconnected, my signal generator was still outputting stray RF, and the active probe was picking it up and displaying it on the spectrum analyzer, even though it was not connected to the signal generator. So so the RF is there, that's just the lead from the the lead that's coming off of the signal generator, which is maybe a couple of feet long at most. And having said that, even when you open up the output to the SIG-Gen, you can still get some stray RF. Now, granted, it's very low power, but it's still there.
In my case, it was low, but enough for the receiver to pick it up.
Yeah. Now, how low is low? I couldn't tell you off the top.
Oh, it's been a couple of weeks, but it was it was certainly there, measurable on the scope.
Yeah. Oh, there.
Maybe my ultimate solution is to key the power supply instead of keying the output driver.
Key clicks.
There you go. Okay, thanks, Al, for sharing that with us. Charlie, what's moving and shaking on your bench?
I haven't been here for quite some time. A few months ago, I signed up to put together an all-star node for the Kingston Club, and the Kingston Club has moved their regular monthly meetings to this night, and I've been going to that meeting to report on progress on that node, so I haven't been able to make it here for a while. The thing is mostly done now, a little bit of debugging left, so hopefully I'll be able to attend here more regularly. I've been working on EPRS units that are based on direwolf for deployment with my buddies in the Yukon to measure their 20-odd mountaintop repeaters, keep an eye on the voltage and temperatures that are going on up there, and so on. Last month I was up there for a few weeks and did maintenance and installed a few of these on some mountaintop sites. So that was kind of fun and exciting. Got to see everybody up there again. And I've been getting boards from JLC PCB that Peter pointed out to me when we were having coffee one morning. And my APRS boards I've been putting together here and then age testing them for a while before deploying them in the field on mountaintops. But that's it's Raspberry Pi based design. Has a few extra funky features, but primarily it's measuring multiple voltages and temperatures and so on.
Okay. Peter.
Muted, Peter. Sorry.
Yep.
You're
Peter,
muted, Peter.
actually, that's better.
Sorry, it just occurred to me. Are you throwing those boards into the freezer to test them before you send them off to the Yukon?
My
Eh?
my early prototypes ran in my trailer all winter, just to make sure that the Raspberry Pi in particular, I was wondering how it was going to behave over the course of cold temperatures. We did have that one kind of minus 30 something night here, which is more what you'd experience on some of those mountaintops in the wintertime for sure. But it seemed to keep on ticking. No real issues. And I have some other Raspberry Pi based earlier versions of this that have been running, over the winter in the Yukon, not on a mountaintop, but in their communications trailer. So temperature seems to. We're certainly I'm beyond what it's spec'd for, but it seems to be happy.
All right, Charlie, does that All-Star node that you're working on have a number assigned to it yet?
Yes, it does, but I'd have to look it up. I don't know it off the top of my head.
Okay. All right. Yeah, just curious. All right.
I'll drop you a note, Eric, once I look it up.
Yeah. You expect it to be active?
It's up right now, but one of the issues I'm having with it is I'm using an older 2-meter radio to access the repeater, basically as sort of a remote base approach. And it, for some reason, the radio is required to put out a signal which says I'm receiving something. It's either driven by the tone detector or by the squelch opening. And for some reason, there's a bit of a delay there that doesn't quite make sense to me. And I don't know if it's an issue with the radio because it's a late 70s, early 80s vintage Radio Shack mobile that I'm using, or if it's just a timing error in the software or something. But it tends to cut off the first, if I'm getting it to report weather conditions or something, it cuts off the first few words and then works okay after that. So.
Okay, fair enough. All right, thanks, Charlie, for sharing that. Appreciate it. Okay, Dwayne, what's happening down in your neck of the woods?
Haven't been doing too much radio stuff. I've been laying out a couple of circuit boards. I'm going to get around to etching one of these days, and these are all surface mount. And to put them together, I just bought a new toy I want to play with. This is a little heat plate, 120 watt heat plate. I got a variable power supply for it, and I use that for heating up and doing the surface mount components. Seeing if that works any easier than using a hot air gun on them. Keeps from blowing around a little bit. This way it heats up the substrate first and kind of holds everything in place until they get in position and everything warms up enough for the solder to flow. And that's been just about it.
Yeah, I've seen hot plates used, I think, for that purpose, but that probably is a lot more money than what you've got in your hand there. So, good. All right, Frank, I've got you next in line.
Okay, my adventures have been with the Hot Water 9, HW9 Heathkit. And it was put on the shelf for a few weeks because I was missing a shield, as I mentioned last time. Anyway, someone had suggested that I contact the HW9 users group and ask a question whether anybody had one of these shields or the complete part, whatever. So what happened then was I got two replies. One of them said, well, I don't have the shield, but if you go into the Heathkit site, they have all the old stock that's left over from Heathkit. So that was interesting because I didn't realize that anything to do with Heathkit was still active. Going into their site, I find out that they're still making a kit, either kit form or already built, but it's very limited. It's like a tabletop FM radio for just regular FM stations. Nothing to do with ham radio at all. But they do have a complete listing of all the parts they have in stock using the Heathkit part numbers. So I went down that in hopes of finding the part number for the coil. There is no part number for a shield alone, but just the coil. And of course, they didn't have that. But they do have a boneyard, as they call it, with old Heathkits in it. And they might be able to take a part off or something like that. So I wrote them a letter and told them what I was looking for and everything. Well, I haven't heard back from them yet. But in the meantime, there was another ham that says, well, I have some shields that measure, I wanted 7 by 7 by 12 millimeters, and his were 7 by 7 by 10. So I thought about it and I said, gee, if I just solder a wire onto it, I can extend it into the circuit board and ground the leads on the other side of the board. So I wrote back to him and told him, yes, I'd like to give it a try. I think it'll work. One of the other questions is whether they had a hole in the top for the adjustment of the slug that's in the coil. And he wrote back, said, yes, they do have that. So I told him, well, send me one and let me know what the charges are and I'll pay for the shipping and anything else. So a day later, this ham, who was Sam Delaney, is KB8E. And he wrote back and said, yep, I'll send you a couple. And the shipping's on me. So that was a nice surprise. A couple of days later then, this package arrived at my doorstep from the FedEx truck pulled up. And it was a box about 10 inches, a cube, 10 inches by 10 inches by 10 inches. And I took it in, very light, and opened it up and dug through a whole bunch of packing. And lo and behold, there was a plastic envelope with 7 of these shields in it, all courtesy of KB8E. So I tried putting the coil inside one, and that worked perfectly. And then I shoved it all the way in and then mounted it, and the darn thing works like a glove. Fantastic. So the HW8 is back on the bench again, and I run into one little problem with it. There's a switch shaft, which is about 7 inches long, and it has to slide through a bushing on the front panel. And lo and behold, I couldn't get that thing through the bushing for love nor money. So I got some, sort of a nylon, Teflon type material. And I think over the years, it must have swollen. So I got some 320 sandpaper, And I spent a couple of days just smoothing this thing off, rounding it, make sure it was perfect. And I got it to slide through the bearing and slide through the four different switches that are there. And it's for the band switching anyway. So slow but sure, the HW9 will come to life. And that's about it for now. Back to you, Eric.
Okay.
What a
Thank you
great
very-
story.
Yeah, yeah. That restores faith in the ham community, doesn't it? So,
Oh, I'll tell you.
well, there you go. You got to remember to pay it forward, I guess. That's the lesson here as well, right? For everybody. So,
Mhm.
yeah, nice. That's good to hear. So, Hassan, what's going on with you?
You took the words right out of my mouth. Pay it forward. So I'm building up some goodwill with my wife by doing yard projects with her. And so I'm doing refinishing her backyard table, and I put some extra lighting in my garage so I can actually use it and clean it up a bit. So yeah, laying the groundwork for some radio time in the fall, hopefully.
Right, right. Earning some credits for radio time.
Yes.
All right. Okay. Very good. Michael, how about yourself?
Well, really what I've been doing is trying to understand how this splitter thing works and figuring all that out. And that's taken most of my time, really. The comments about radio, I was thinking, we're going to be going camping in September, and I'm thinking about, I have a 40-meter QCX, and I'm thinking maybe I'll take it with me and see if I can figure out a way to get my quarter wave vertical up easily. It's one of those. It's one with raised radials, a couple of raised radials. So I might try to do that. So I've at least thought about that. I haven't actually done anything yet. That'll be the next thing, to actually try it out here and see if I can get the QCX to work properly here, and then maybe take it up with me when we go. Anyway, that's all I'm doing right now.
Okay. All right. Thanks, Michael. Wayne, how about yourself?
Well, I haven't been doing too much because I've been spending way too much time making measurements related to the paper I'll be talking about in the next meeting. But I just started to pick up my tunable preamplifier that I was working on a long time ago as a sort of front end for the direct conversion receiver whenever that kit becomes ready. So, well, that's basically it. That's all I got. I just started working on it 2 days ago, and I've been playing with seeing if I can get a good tuning range with some varactors and a good cue for the first and the second resonator in the chain. That's my story.
All right. You got that presentation that'll be for the meeting later this month, or is that for another?
It's this month sometimes.
This month, yeah.
16th,
Okay.
I think.
Right. Yeah. Okay. Oh, very good. All right. Thank you, Wayne. And last but not least is Howard. Yes.
No, I haven't been doing too much. I've been away for a bit, and then some summer stuff. But I did have this last minute act that I acquired from an auction, and I don't know if it's going to turn. I'll screen share it. I don't know if it's going to turn into a project or just decoration. Let me see if I can see it. If you can see it, can you see that?
It's coming. There we go. Yep.
This is like, I had no idea what it was, and I was going away the next day, so I put this low bid in for this, and it was like $10, and it's this regen receiver from 1930, and I haven't had time to do any research or anything on it. So, but I thought it looked kind of cool, so I guess that one knob on the left obviously isn't original, but maybe a 3D it or something. But so that's the one. You want to go ahead, Peter?
Peter, yeah.
I was just going to say, if you have questions about that, we have a guy in our group who's well into vintage radio stuff.
Oh yeah.
So he doesn't really join into these meetings, but I'm thinking of Simon. So if you have questions, we certainly have some resources within the group.
Oh, okay. And I don't know, can you see this one?
Pardon me?
Can you see the next one?
Not yet. It's still on the transatlantic.
Oh, okay. Hang on. Let me just. I'll stop sharing and then show you the next one. Oh darn! Push the wrong. Hang on a sec. Sorry.
Looked like your pictures were lined up along the bottom of that screen you were on.
Yeah. Not sure why that happened. Here, let me try it again. There we go. Can you see that?
Yep. There we go. Yep.
And I had no idea about this, but I know people talked about Helicrafters, so another low bid, and then I got this. So I think this is from the 50s because it has a sticker on the side that says 1950. But this one actually has a cord with it. But so I don't know. I don't know. I might play around with that or just have it as decoration. Something to do in the winter. So that's pretty well it for me.
Well, for the prices, you can't go wrong by the looks of it. So.
Well, like I say, I just put these really low bids in, and because I didn't know anything about it, and sure enough, I got them. And
estate sale?
Yeah, it was an estate sale through the Ottawa Antique Radio Club.
Right.
I bet you could sell them to Eric for a profit.
Oh. I got my 2 transoceanics I still have to play with, but they certainly were more than $10. That's for sure.
Yeah, I thought about that when I was looking at what they had, and they did have one, but it was up around 200 something already for the bid.
Okay, yeah, but no, even if they don't get much use out of them, they'll look nice on the shelf. The wall behind your head kind of thing. So
that's what I thought. I mean, all the tubes are in there for both of them, so we'll see.
Yeah, very nice. Okay, thanks, Howard. All right, and that is it. We've gone around my screen, so that's really the end of the meeting, unless anyone has any other things they'd like to bring up. As Wayne mentioned, our next meeting is a regular one, the 16th, Wednesday, the 16th of August, a couple of weeks from now. So that'll be our last meeting of the summer, believe it or not, but it's going by fast. So, all right. Well, thank you very much, all of you, for attending. Appreciate coming out, even though we're all busy with other things this time of year. Message for you, Peter, there in the chat. You hopefully saw. So on that note, I'll say 7-3 to y'all and see you in a couple weeks.
Right.
All right. Thanks.
73, everyone.
Yeah,
Right.
73 to all.
Good night.
You see my message, Peter?
Yeah, he's Simon is a member of SOAREX, so he is on the group's IO.
Oh, it's Simon. Oh, I never remember seeing a Simon. I don't know.
Yeah, Simon Cotton. What's his call? I forget his call sign now. But
Okay.
you can always try posting a question on there. I don't know how often he frequents the thing, and if he does, if you do a question on the are you still recording there, Eric?
Yeah, sorry, let me stop that.
Yeah, if he doesn't answer in a time within, then